In this nugget, we will explore the context of how an application is launched as a key control to minimize risk and achieve least privilege when deciding to allow or elevate the application. The context of an application's launch refers to the specific circumstances or conditions under which it was started. For instance, launching a web browser by clicking its desktop icon differs from launching it via a command line with specific parameters to open a particular website. We'll also provide examples of when and how to leverage this control and incorporate these into your EPM policies. The basic approach to privilege management and application control often focuses on granting users the permissions and applications they need for their role. However, this may not be sufficient to reduce risk, especially if the application is susceptible to misuse or can be leveraged for unintended purposes. In such cases, how an application is invoked becomes just as important as ensuring it is granted the correct permissions and only to the necessary users. This has always been the case, but the need to add this context is becoming more important as attackers adapt to application control as a prevalent security measure in most enterprises, in an approach referred to as living off the land. Living off the land is a technique used by attackers where they exploit legitimate system tools and built-in functionalities to carry out malicious activities. This approach allows them to stay undetected for longer periods because they are using trusted applications and processes that are already present on the system. Some applications are more susceptible to this approach than others, and there are excellent online repositories maintained by the community that can be referenced when building policies. As an example, let's look at applications that fall under the category of content handlers. So, what do we mean by content handlers? Simply put, these are applications that work with various types of content, such as emails, web pages, documents, and pictures that can contain malicious payloads that exploit powerful built-in tools and script interpreters. These built-in tools have legitimate uses, so we can't just block their usage without impacting usability. However, by invoking context, we can prevent built-in tools as well as unsigned or unknown applications from being executed by content handlers. Preventing content handlers from launching these tools is a huge risk reduction that defeats attacks early in the execution chain without impacting the user experience. To implement this in policy, we first need to define our content handlers and place those in an application group. Next, we create a policy for the tools that we want to block, such as script interpreters and unsigned apps. We then set the parameter, parent process, to the application group containing the definitions for our content handlers. If you are using the Quick Start policies, this use case is already built out for you in the Policy 2.0, Quick Start, Common Attack Vectors. You can review this as an example of how to use the invoking parent process as context to blocking applications that you would otherwise allow. If you are not familiar with Quick Start, there are video nuggets in this series on the topic that you will find useful. To illustrate this further, let's consider a more complex use case. Instead of blocking an application, if it is launched by a vulnerable app, we want to block an application that can be misused unless it is being used by a specific app. In this example, we'll use MSBuild.exe, an executable identified on Lolbast as susceptible to exploitation. MSBuild, or Microsoft Build Engine, is a tool for compiling code into executables. While it's mainly used with Visual Studio, it's also part of the .NET framework. This widespread presence makes it an attractive target for attackers, as it can be found on most endpoints, even those not used by developers. This allows attackers to compile their exploits directly on the target system, helping them evade detection. To prevent MSBuild from being weaponized, we need two policies. The first, to allow MSBuild if Visual Studio is the parent process, and the second, to block MSBuild for any other use. As in the previous example, the first step is to create a secure definition of Visual Studio and place it in an application group, which we will use to set the parent context. Next, we create an allow policy for MSBuild and set the parent process parameter to the application group containing the Visual Studio definition. Finally, we create a block policy with a lower priority to ensure it is evaluated after the first policy, which defines MSBuild without a parent process context. Note, this was just an illustration of how to order policies to ensure the definitions are evaluated correctly. These examples do not require individual dedicated policies. Where appropriate, you should incorporate the use case into an existing policy framework. This will promote scalability and ease management overhead. We hope this nugget has enhanced your understanding of how context can be employed to shield vulnerable and high-risk apps from being misused, and that the provided examples are helpful in incorporating these controls into your EPM policies. Thank you for watching.